Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, let's begin this problem by looking at a top-down view of the ground, or at least a rectangular or portion of it. In this view, directly up will be towards the north, directly down towards the south. To the right would be east, and to the left would be west. Now, we're given that the horizontal component of the magnetic field is headed directly to the north, and we know that a proton, which we'll represent here as a dot with charge plus E, is headed directly to the east at some velocity v. We're given that the speed of this proton is such that the magnetic force that the proton feels is equal and opposite to the weight that the proton feels due to gravity. If we use the right-hand rule, we see that the magnetic force is directed out of the screen, or directly up, and we represent that as a dot with a circle around it. And of course, the gravitational force is going to be headed directly downward, because it's going to go towards the ground, and that is represented as a vector with that's an X with a circle around it. Now, because we know that they're balanced, we know that the magnitudes of these forces are also balanced. So, we can say that the magnitude of the magnetic force is equal to the magnitude of the gravitational force, of course, acting on this proton. From the textbook, right, the magnitude of the magnetic force is given by the charge of the particle multiplied by its speed, multiplied by the magnitude of the magnetic field through which the particle is traveling, and then lastly multiplied by the sine of the angle between the magnetic field vector and the velocity vector of the object we care about. And that's going to be equal to the gravitational force of this on this object, and that is just the mass of that object, or the proton, multiplied by the acceleration due to gravity. The question asks, what speed allows for this balance? That means we want to solve for the variable v, and we're going to do that now. So rearranging the equation, we see that v is equal to the mass of the proton multiplied by the acceleration due to gravity divided by the charge of our proton multiplied by the magnitude of the magnetic field, and then again multiplied by the angle between our magnetic field vector and our velocity vector. If we look back up at our diagram at the top left, we see that the angle between the two, when we put them tail to tail, is 90 degrees. We put in sine of 90 degrees, and of course that value is equal to 1. So ultimately, in the end, we're solving for the speed of this proton given by these values. So it's the mass of the proton times the acceleration due to gravity divided by the charge of the proton magnitude multiplied by the magnitude of the magnetic field through which the proton is traveling. So the mass of our proton is about 1.7 times 10 to the negative 27 kilograms. Acceleration due to gravity, of course, is 9.1 meters per second squared, divided by the charge of a proton, 1.6 times 10 to the negative 19 coulombs, multiplied by the magnitude of the magnetic field that we are given, 2.5 times 10 to the negative 5 teslas. When we multiply all this and divide all this out, we see that the speed of this proton is about 0.0041 meters per second, which is the same as 4.1 times 10 to the negative 3 meters per second, which is our answer.